Black holes are one of the most engrossing objects in our universe, and also the most mysterious.
Day after day, our fascination for these celestial objects is growing, as we have been for decades trying to understand them without success.
So what are exactly these black holes? Where do they come from? And why are they so special?
Black holes are regions in space where the gravitational pull is so strong that even the light, the fastest and lightest entity of the universe, can't escape. And without light coming out of them, these objects are making themselves invisible to us.
If you ever look at the recent picture of M87 black hole, what you'll be seeing is what we call the event horizon, a point of no return where we can see small deviation of light.
Black holes are bending space-time so much that they create a single point in the universe where our laws of physics are broken and unusable. If by any chance someone or something crosses the event horizon, it would be doomed to fall into its center unless it travels faster than the speed of light, which is in short terms impossible.
For the moment, we can describe black holes as an angry little black sphere that sucks everything getting too close to it. But if the black sphere is the black part, what is the whole part of a black hole?
It's the singularity. Another mysterious part of the black hole that we're not sure about is its true nature, and we don't know yet what it is exactly.
We have to imagine this singularity as a single point with a radius r0 equals to 0, that has no volume and surface, but is infinitely dense. We'll let you some time to spot the incoherence in the space-time equation. Actually, you don't really need to understand it. Well, congratulations, you just broke physics by dividing by 0. And this is the particularity of this singularity.
This is a paradoxical situation, as it is impossible to imagine for us human a point without any surface or volume, having an infinite amount of mass. And as we are speaking right now, scientists still don't know what it is all about. After all, it might be something completely different.
This singularity leads to an extremely chaotic environment, where space and time collapses together, and where the relationship between mathematics and physics, two closely connected fields, is ripped apart. In other words, we no longer have the right tools to explain where these holes lead to.
Some scientists are theorizing about another universe in the other side of these black holes, while others are thinking about a dead end. But how are black holes born?
It might sound crazy, but our sun could one day turn into a black hole.
Well, don't worry, nothing will change for us as we won't cross the event horizon, because the mass of the black hole would be the same, except that we would be freezing to death.
Stars like our sun are giant nuclear stations, where nuclear fusion takes place in the core of the star, squeezing hydrogen atoms into helium, thus releasing a ton of energy. This energy created is pushing against the gravity. As long as an equilibrium position is set between these two forces, we can consider a star as stable, like our sun.
But for much bigger stars, we can observe that successive fusions can occur creating iron.
In the process, the energy created by these fusions is reduced, allowing the gravity to push harder and harder into the core.
When the quantity of iron reaches a critical level, the balance between the nuclear energy and the gravitational pull is disrupted, creating a huge implosion of the star.
This implosion signifies the death of the star and what we call supernova. These supernova produce either a white dwarf, or if the star is massive enough, this will create a black hole.
These black holes can be of various sizes. They can have a small diameter of 20 kilometers, or they can even be thousands of times bigger than our sun. These giant black holes are also usually found in the center of our galaxy.
We've been talking all along this video about black holes. But what if we told you that white holes exist and can create connected to a black hole what we call a wormhole? Wormholes are a kind of bridges that allows us to travel from a point A to a point B by bending space-time itself. But these bridges, known as Einstein-Rosen bridges, are so tight that we would be dismembered at the other end. Other kinds of bridges are theorized and proved mathematically. Unfortunately, mathematics do not represent the total reality of the space entities.
But what if you fell into a black hole? Or worse, a wormhole?
Could these wormholes one day allow us to travel in time? How could we travel in it then? Well, this is a story for another what if.